So what you've done before is simplify. If you look at your function, the things you had, the last handout, there weren't any equal signs. Here, there's an x with an equal sign in it. Everyone see the equal sign?
Mm-hmm.
You can only solve for x if there's an equal sign.
Oh.
So all the ones you had before, you couldn't solve for anything because you did not have equal signs. Now we can solve for x because you know that two things equal each other. So now I can solve for what x is. Do you see what I'm saying? We're giving you an equal sign in the problem. If you look at all the handouts, all the last handout, there are no equal signs in there anywhere. Right? You put some equal signs in, but they did not say anything equals.
Right.
So now you can say we can solve for x. So how do I solve for x? Get the square root symbol by itself, and then square both sides. So here, the first one's already done for me, the square root symbol's by itself. So everybody square both sides. So I'm going to square this side, and I'm going to square that side. So square root squared, I'm going to get x minus 5. Well, let me start over. How do you undo a square root? Square it. Does everyone understand?
You mean exponents, yeah.
Well, how do you undo a square root? You square it.
Yeah.
Squaring something undoes a square root. How do you undo a square? You square root it. So squaring and square rooting undo each other. So that's why I'm going to square both sides, because they'll undo the square root and the square root will just go away. So everybody understand why we're doing that now? So here, I'm going to square this side. I'm going to square this side. And so squaring this side will make that whole part go away. X minus 5. Makes the square root go away. What's 7 squared? 49. Perfect. And now how do I solve for x? What do I do to both sides to get just x?
Minus 5?
Well, I have minus 5 already. Then I'd have minus 10.
Oh, plus 5.
Plus 5.
Yeah.
So then I end up with x equals 54. Let's say I had a more complicated one. I'm going to do a different one so you don't have quite the same one on your sheet. Well, let me see what we've got here. Yep, so say I had 5 plus the square root of 4 minus x equals 12. Okay, what's the first thing I want to do?
Square it.
Nope, you need to get, if I squared it, I'd have to FOIL it this times that, I'd have to do this. Right, that'd be a total nightmare. I'd have to FOIL this by itself. So I'd have to do this times that, this times that, this times that, that times that. That's a total nightmare. Everybody agree?
Yeah.
We do not want to do that. So instead, the simpler thing to do is to just get the square root by itself first. How do we get the square root by itself first? Get rid of the 5. So what's up with the 5? Is it being multiplied by 5, divided by 5, added to 5, or subtracted? What's up with the 5?
Added.
It's being added. So how do I get rid of that? Subtract. Subtract what? 5 from both sides.
Okay.
Does everyone see why we're doing that? When we get the square root all by itself, I need to get rid of this guy right here. How do I get rid of 5? Minus 5. Both sides. I'm done. So here I'll end up with square root of 4 minus x equals 7. Oh, I've got 7 again. Whoops. Now I have the radical by itself. I can square both sides. Squared. Squared. What do we get? 4 minus x equals 49. Okay, so now I can, what's my next step?
Add 5.
Add 5? Are you in the same problem I'm at? I'm on the right, I'm on the...
Well, add 4.
If I add 4, then I'll have 8 on the left. I have $4 and I owe a skateboard. How do I get rid of the $4? Minus 4.
Oh, you minus?
Because is my 4 plus or negative? It's a positive 4. So to get rid of the positive 4, I need to subtract 4.
Well, I guess the negative threw me on the other side.
Yeah,
of
so
that
remember
thing.
the sign always belongs to the one after it.
Oh.
That's why we gave this to you, to kind of throw you off a little bit. Okay, so this, really remember that goes with that. So I'll end up with negative x equals 45. Multiply both sides by -1, or add or divide both sides by -1, either way. Do you guys want to do the divide, or do you want to do the multiply? I can do the multiply. Multiply by -1. X equals negative 45. Okay, so there are 4 more. Let's give folks 5 minutes to go to work on these, 7 minutes to work on these, and then we'll go over them.
Yeah.
So number 2, I'll go through number 2. I need to get my screw by itself. So let me just draw my little line down here. I'm going to subtract 3 from both sides. And we'll end up with negative square root of 6 minus x equals -1. And then I can, it's kind of by itself, it's just negative. So I can square both sides, it's totally fine. Make sure you square both of them. If I square a negative, right, this is negative square root, but when you square a negative, it becomes a positive. So both of them become positive. This becomes what's inside 6 minus x and positive 1. All right, so then I'm going to subtract 6 on both sides. And you folks got negative x equals -5, which means that when I multiply both sides by 1, x equals 5. Okay, so looking at the next one. 3, 4, and 5. So you had a question. So if I have negative x, I want positive x. So I'm going to multiply both sides by -1. So then I end up with positive x, because I need to have positive x. All right, so here, I'm first going to draw my little line down the middle. I need the square root by itself, so I'm going to add 4 to both sides. And I'll end up with square root of x equals 9. I'm going to square both sides. And I end up with x equals 81. That was nice and simple, right? Okay, good. Next one, now this is a cube root. So here, the cube root's by itself, but remember I need to cube both sides, raise both sides to the 3rd power. So here I have x plus 2. Over here, 2 to the 3rd power is 8. And then I'll subtract 2 from both sides. And I get x equals 6. All right, the last one. I need to get rid of this 2 first. I need to get this cube root by itself. So I'm going to subtract, draw my line. Subtract 2 from both sides. I'll get the cube root of x. All right, I owe $3, and now I owe $2 more. Altogether, I owe $5. So it becomes -5. When I cube both sides, raise both sides to the 3rd power, -5 stays negative. It's negative 125. Right, negative times negative times negative is a negative. Right, so negative 125. X equals negative 125. Okay. So those are those ones. We have a few more minutes. So let's go ahead and take a look at the next page down. All right, so these are the basic graphs of the square root function and the cube function. So what are the, what are the x, so remember the x-intercepts are where it intersects the x-axis. Y-intercept is where it intersects the y-axis. So this first one over here, where does it intersect the x-axis?
Zero.
Yeah, right here. Right here it intersects the x-axis. Where does it intersect the y-axis? Where does it intersect this axis here? Also 0. Right, so this is going to be 0, 0. And the other one is also 0, 0. They're both 0, 0. Okay. How about this one over here? Where does it intersect the x-axis? Right here, 0, 0. Where does it intersect the y-axis? Also 0, 0. So these are also both 0, 0. And that's kind of, that's where it's centered. So that's kind of the nice thing about them. They're all centered at 0, 0. They all intersect the x and y axis at 0, 0. But what happens is as we shift it, things change. So we're going to shift, we're just going to do number 1, and then we're going to move on to one of the other problems so that we have a little taste of it, and then we can remind ourselves about it on Monday. So here, I'm going to shift the square root of x 1 down. So I start off at 0, 0, and I go 1 down. What's my new point? What's my new center? I'm going to put it, mark in your new center. Mark it in where it goes. Down 1. 1 down. Where is that? Here's my center. 1 down is right there. Yeah?
Negative 1, 0.
Okay, great. Now, draw in your other 3 points. It's a swish, right? Remember the swish thing?
Oh,
Remember I told you have that other handout handy?
1.
So you should have it handy. I told you you're going to be referring to it a lot whenever you do graphs. Everybody pull it out if you need it. You need the other 4 points, the other 3 points. Find it. Looks like this, right?
Oh, this is like.
We filled on those points. Remember these? That handout. Fill them all out. That was our Bible. Do you have it? Or do you have the points, David? Do you have it? Do you have your points? What are the other 3 ones? Oh yeah, show them this. They hit the sheet. Where's it go? From the center, it goes over 1, up 1. Okay, so from our center, we go over 1 and up 1. And then, again, from our new center, we go over 4 and up 2. And the last one is from our new center, we go over 9, up 3. So there's our new, looks sort of like that. What's the x-intercept of the shifted graph? Where did it hit the x-axis?
0.
Nope. Where did the x-axis? Here's my x-axis. Where did it hit it?
1.
Right here. Yeah, at 1, comma 0.
So we're looking at the first one?
No, we're looking at we're looking at the top graph. Looking at these intercepts here. Where does this graph hit it? It hits it.
Oh, hit it. The
right
line
here.
hits it. Okay. I get
Yeah.
you. Oh,
That's the intercept. Where does it hit it? It hits it at the intercept.
okay.
What is the y-intercept of the shifted graph? Where does it hit the y-axis?
-1, 0.
Yep, right here. -1. So 0 is my left, right. My height is -1. So 0, -1. What effect does shifting graphs have on the intercepts? I don't know. It moved them. I have no idea what they mean by that. I and write this.
I think it's because before there were no intercepts.
Well, 0, 0. 0, 0.
Well, 0, 0, but basically what it is, instead of having just 1 point for the intercepts, it has 2.
Right. There are now 2. That works. There are, well, they're different. They are different. Because there are always 2, but they're just the same one. They are different. Okay. Now I want to jump down to, we're going to skip 2 because I want to do 2 again next class so that we have a little bit of refresher. And we're going to drop down to the very bottom page. So here's the thing. There are ways of finding the y-intercept and the x-intercept. What's up with the y-intercept? Here's the y-intercept right here. It's this one, 0, -1. What's up with it? What's going on? Y can be anything on the y-intercept. So everyone see as I move my pen along this line? But the x stays the same. X is what? All along this line, what's x?
0.
0. So here, so the y-intercept says, what is y when, write this down, when x equals 0. Likewise, the x-intercept, the x changes, but the y stays at 0. So the x-intercept says, what is x when y equals 0? And you look at it. See, if you look at the point, y is 0, x is 1. Below the y-intercept, x is 0, y is -1. So the deal is that on the y-intercepts, the y, the blue one, is 0. Right here with the x, the y-intercept, the x is 0, the y is the one that moves around. I think I said that wrong. The y-intercept says, what is y when x is 0? So that's kind of how I like to think about it, because I think my initial thought is, oh, y-intercept, y is 0. No. Y-intercept, what is y when x is 0? Right? Think of it that way. And then that'll make it easier for you. So here, y-intercept, find x is 0. When x is 0, find y. For the x-intercept, y is 0, find x. So we're out of time, so we'll get back to that next class. But, well, should I just do number 1 with you quickly first? Okay, so here, my y-intercept, I'm going to make x 0. So here, this is y equals square root of x minus 2. I'm going to do y equals square root of 0 minus 2. Well, square root of 0 is just 0. Y equals -2. So it's going to be 0, -2. For the x-intercept, I'm going to make my y 0. So 0 equals square root of x minus 2. Add 2 to both sides. And I'll get 2 equals square root of x. Now I'm going to square both sides. So then x equals 4. So this will be 4, 0. Done. All right. We'll go over it more next class, but I wanted you to just get a sense of it just to start off with a little bit. If you want some help with things, June, our wonderful tutor, will be here. She'll be here till 1:40. So if you have any questions about anything we did today, just keep working on things. Feel free to. She'll be here.